In today's manufacturing workflows, seamless communication between design and manufacturing departments remains as critical as ever. The 3D models created by designers are rarely just individual parts. More often, these parts are engineered to function in coordination with others. That's where assembly models come into play. They allow you to clearly visualize the positional and functional relationship between the part to be machined and its surrounding components. This clarity helps CAM programmers instantly understand how parts are connected, which surfaces are in contact or interacting, and which areas require clamping or fixturing. As a result, the manufacturing process becomes more predictable, safer, and less prone to error. Assembly models also enhance communication between the design engineer and the CAM operator. Verbal or written explanations are often not enough, and that's where a visual representation of the complete assembly can eliminate miscommunication and speed up the entire workflow. Models that are prepared during the design phase are natively supported in EZCAM's CAM environment, meaning the entire assembly, not just a single part, can be transferred into the CAM system. This allows the operator to clearly evaluate fixturing, clamping points, and the spatial relationships between components. By doing so, programming steps can be executed with increased confidence, and potential risks during machining can be greatly reduced. In earlier versions of EZCAM, importing a solid model would result in all parts of the assembly being automatically placed on different layers. Users could then use the Edit Layers command to hide unnecessary components or create custom groupings by adding new layers. However, in larger assemblies with many components, the layer list would become cumbersome, making it difficult to locate specific parts and wasting valuable time. To simplify this workflow and make working with assemblies more efficient, we've introduced significant improvements through our integration with Alibre Design. In the latest version, the EZCAM add-on for Alibre enables a direct, reliable, and user-friendly transfer of part, stock, and fixture data from an assembly environment. You can now select the specific part to be machined directly from within the Alibre assembly, easily define clamping elements and fixture components. Send everything with a single click to the EZCAM workspace. Let's now take a look at how these improvements enhance the CAM workflow. Assembly workflow demonstration in Alibre. We begin by opening an assembly file in Alibre Design. The workspace displays all components together, allowing for a complete visual of the working model. On the left, you see the part list and the hierarchical assembly tree. You can easily select and inspect any component from this list. The center area provides a fully interactive 3D visualization zone where you can rotate parts, zoom in, out, and change viewing angles as needed. At the top, the Assembly Tools toolbar provides all necessary commands for dimensioning, view control, and assembly manipulation. Syncing EZCAM and Alibre. Under the Add-on tab, you'll find the EZCAM Sync commands. These tools allow you to establish a connection between Alibre and EZCAM effortlessly. Next, we'll explore how these commands function and walk through a real-world example of preparing an assembly for machining in EZCAM. Let's continue with a simple example made up of a few components. In CAM workflows, we typically deal with three fundamental element types. These form the backbone of all our projects. Part, the actual model we want to machine, our target geometry. Stock, the raw material from which the part will be machined. Fixture, vices, clamps, and other holding elements used to secure the part. Whether you're working in the milling or turning interface, these three categories are always relevant. Even in complex assemblies with many components, everything can still be grouped under these three main headings. Important, you are not required to transfer all these elements into the CAM environment for every operation. We want to emphasize that. Let's now show how to transfer a part into EZCAM. It doesn't matter whether the model is your own design or comes from an external assembly file. Once opened in Alibre, you can make all necessary adjustments and isolate the required components. To begin, activate only the element you wish to transfer. For example, if you don't want to include ejector pins, bolts, or nuts in this mold assembly, simply isolate the model you want to machine. You can do this by selecting the part in the design tree or by right-clicking on it in the 3D view and choosing Edit Here or Edit in separate window. This will effectively deactivate all other components. To transfer the part, go to the Add-ons tab and run the Transfer Part command. The selected model will be automatically sent to the open EZCAM window. Tip: if you later make any modifications to the part, you can retransfer it the same way, as many times as needed. Once the part has been transferred, the next step is to bring in the stock model. Right-click in an empty area and choose Edit Root Assembly. This reactivates all the components that were previously deactivated. Then, select the stock model and run Edit here. From the Add-ons menu, this time select Transfer Stock. Your stock model will now be transferred to EZCAM and is ready for subsequent operations. There's no need for additional setup. The transferred stock is automatically named and configured for simulation and toolpath generation. You can even assign this stock model as a check surface to define the material between stock and part, or simply use it for simulation purposes. With the stock now transferred, the remaining components can be treated as fixtures. Again, right-click an empty area and select Edit Root Assembly. This brings all components back to active status. Now we need to hide the already transferred parts. Use Hide or Suppress to remove them from the view. We prefer using Hide so that only the clamping elements and other fixtures remain visible on screen. Finally, run the Transfer Fixture command to send all remaining visible parts to EZCAM in one go. At this point, we've completed all the critical steps that impact toolpath generation. Your workspace is visually ready, and all clamping and fixture elements are now included for safety. This minimizes potential errors due to oversight or distraction during CAM programming. What if a fixture causes interference during tool movements? If you forget to select them as check surfaces, EZCAM's collision detection will notify you during simulation. At the end of our video, let's quickly take a look at the ways to include our stock surfaces and fixtures into the process using two parts. After the transfer is completed, you can see that all parts are automatically placed into layers inside EZCAM. Parts transferred as stock are named Stock CRF, and parts transferred as fixtures are named Fixture CRF. This automatic naming makes it easier to select items from the list during operations, such as rotation or translation. It also makes them visible in the simulation, preventing the user from wasting time on manual naming. More importantly, it plays a critical role in generating the desired toolpath correctly. In this model, the goal is to machine the material left between the stock and the part. After selecting pocketing and HSM as the operation, tool, depth, step over, and similar values are filled in on the open dialog, and then the surface selection step is performed. In fact, as I am doing right now, you can also choose one of the previously saved operation or tool templates to minimize the time spent on this first step. After quickly checking all the information on the page, let's move on to surface selection. Machining surfaces in this step allow the user to partially select the regions to be machined on the part by using Smart Click. In my current example, the entire model needs to be selected, so I hold down the left mouse button and frame the whole model. Then on the right side, I can define to the program that I want the area between the stock and the part to be machined. For this, after clicking the Control Surface command and selecting the stock, we can check the result with Calculate Toolpath. In this example, I don't need to include my fixtures as check surfaces because I am already working at a sufficiently safe distance. However, in another example, we will also demonstrate how fixtures can be included in the process. This time we are working on a mold model which consists of the part, the stock, and the fixture elements. Unlike the previous example, in the 3D machining wizard, we activate the stock milling option. We also add the clamping elements, which were transferred as fixture elements, as check surfaces together with the stock. In this case, EZCAM will machine the areas between the stock and the part. And while doing so, it will automatically apply the necessary offset adjustments to avoid touching the clamping elements included in the control surfaces. You don't need to worry about the clearance levels of the clamping elements. While the user-defined clearance level is applied for the middle sections of the mold, Z levels for the rapids over the clamping elements are adjusted automatically. Also, don't forget that you can define as much side clearance as you want for the fixtures.